Good morning, everybody. Thanks for coming to my talk. My name is David Bain, and I am from the University of the West Indies in Jamaica. I've been using Plone for a while, and I was bitten by open source stuff in about 1998. That's around the time that they actually coined the phrase open source. So, my first degree is actually in zoology, marine and stuff like that. I usually tell people that first to scare them. So that, why are you talking about technology stuff? And at the University of the West Indies, I work at a department called CARIMAC. That's the Caribbean Institute of Media and Communication. I've been tinkering with ec2 for a few months, and I'm not assuming everybody knows what ec2 stands for, so I do have a glossary of acronyms that I'm going to go through. And I'm the founding partner of perhaps Jamaica's only plone consultancy, which is Alteru Consulting Group. We actually started out as an open source consultancy, and after a year or so, we began to realize that that's kind of broad. So, that's like saying we're a computer consultancy. So we became a little more focused, and we're largely a Plone consultancy. We do other stuff because we have Linux, some amount of Linux expertise and so on. So you and ec2, how many people are familiar, you know what ec2 is? Okay, that's like less than half the audience. Okay. And how many of you are actually using ec2 now? Okay, like 3 people. So I know who to call on to get help during my presentation. Okay, an overview. I'm going to try and break it down into the parts that are used, the methodology that I've been using, and other possible considerations, because the way that I've been going about it is not necessarily the best way. There may be other ways of doing it, and in fact, I have done some ec2 work in different ways. So I'll try and mention some other approaches. I know some people are interested in operating costs and future improvements and things like that. So I'm going to see if I can get into all of that. Right. So what is ec2? ec2 is the Elastic Compute Cloud from Amazon. Basically what that means is lots and lots of machines behaving like a supercomputer. And then in this network of machines, you can launch a virtual machine. And then that virtual machine, you can grow the resources it needs or shrink the resources it needs as you want. Hence, Elastic Compute Cloud. And the rationale behind it initially was more for that calculation intensive stuff. You want to do parallel computing, and you just want to rent some powerful computers for a few hours or a few days to render an animation or something like that. You can always correct me if I'm wrong, for those people who are more familiar with it. It's possible to run an instance of an operating system, a virtual machine. The background and benefits of ec2, you can scale when you need to. There are 3 ways I know of that you can scale. One of them is time. So you don't need to be running all the time, so you can shrink back and say, I'm only going to run this on Mondays. And you only pay for when you run that virtual machine on Mondays. So that would be 1/7 of a normal hosting bill, since you're only running it on one day of the week. You can also scale your quantity. So you might decide, okay, I actually want 3 servers running. Not necessarily all of them the whole time, but there'll be some times when I want to launch more servers and other times when I want to have less servers. And so you can scale quantity. You can also scale in terms of power because Amazon provides different types of these virtual machines. So you can get a large instance or a small instance. I think there's an extra large one now. So you can have different processor powers, and of course you pay more depending on the instance that you want. ec2 is targeted directly at developers. So you can manage it programmatically through their API. The use case that I can bring up is a customer service app that runs only during working hours. So here's a situation where the customer service agents come in at 8 o'clock in the morning and they're answering calls and maybe following a script from a machine that's running on the ec2 cloud, and they only need it 5 days for the week from 8 o'clock to 6 o'clock or whenever. And so you could have a system that wakes up at 8 o'clock, goes back down at 6 o'clock, and the result is quite a bit of saving because it's kind of like an electricity bill. You only pay when you're plugged in. So you just plug it out and you're cool. There is one tiny problem. Previous to a couple weeks ago or maybe a month ago, when you plugged out, all your data went. So it's a little bit of a problem if you're running an app that needs to have, that's tracking data and stuff like that. That problem has been solved though. They now have something called the EBS, the Elastic Block Store, another fun acronym. So with the Elastic Block Store, you can actually store, it's almost like a thumb drive in the cloud. So you can just drop your data onto this giant thumb drive, and then once you bring back up your instance, you can plug that magic thumb drive back into your virtual machine, and bam, you have your data again, okay? So in summary, how does it work? And this is very much the layman's terms summary of how it works. You run a virtual machine, Amazon meters your usage, and you only pay for the time that you use. Reasonable? So for quite a lot of use cases, that's very, very helpful. You're a startup and you may need to run some heavy transactions, but instead of owning the server that runs those transactions, you only wake up that server when you need to run those transactions, and then you just plug it out, and you only pay for what you used, okay? Especially with the whole energy crisis and stuff, you can even claim to be more of a green company. So I was up all night because I really wanted to explain this properly. So I did a little movie. So this is you, right? You is whoever is in the audience there. And this is how Amazon EC2 works. So you get an account from Amazon Web Services, and you tell them a little bit about yourself, and then they give you a certificate, okay? And that certificate says, yes, now you can, okay? So you get this certificate, and you make sure you put it away safely. And this is a digital certificate, so for the programmers, that's how you can identify yourself. And then with your certificate in hand, you can go and start a virtual machine. So you kind of flash the certificate and say, okay, I'm ready to start a virtual machine. And you go to Amazon, here's my certificate, and then you can choose from a bunch of images, okay? So you select the image that you want, and you grab it. Of course, you're going to grab Ubuntu. And And then Amazon starts to meter your usage. Okay? You can put whatever you want on that image because more or less it's just a computer. It's a server in the cloud, except it's virtual, right? So here we are running plone on Ubuntu, as the whole plone community does. And I'm sure other people use Debian. And once you're done, you can just get rid of it and terminate the instance. And Amazon stops metering you. And that's how it works, basically. And you only pay for the time that you use, okay? So that's the version in pictures, okay? Because I know some people, the word thing doesn't resonate as well. Okay. Right. I'm really trying to avoid the cloud jokes. Okay. So I'm not very consistent with this name. I'm thinking maybe this might be the name for it. A simple plone ec2 setup. So I thought Splek might work. That's nice and geeky. It's just not quite recursive, but so the goal is to make it easy to deploy, persistent, and pretty fast to set up. And I should warn you, what I've done so far is very specific to the use case. So I can't quite show you all the scripts because then you're going to know about my client who doesn't want to be known about. But let's see how far we can get. These are some of the terms you definitely want to be familiar with. Elastic Compute Cloud, we spoke about that already. The Elastic Block Storage and the Simple Storage Service. Simple Storage Service, or S3, is Amazon's storage in the cloud. It's a little different from the block storage because it uses its own API, its own programming interface. So you kind of have to know how to speak S3, and you can then grab something from S3 and bring it over to your machine. Okay? So S3 is not as straightforward as block storage because block storage just kind of hooks on to your instance, whereas S3 you kind of have to pull it across. There are some people who have created file systems that kind of make it more transparent so you can use an S3 style file system, but I haven't tinkered with that. And AMI is the Amazon machine image. Okay, so the parts. You're going to need Amazon Web Services. You're going to need some type of ec2 API tool. The default API tool looks something like, that's my client script that you're not supposed to see. Right, and it's on video now. Great. Right. Okay, so let's look at how the API tools look. That is the collection of API tools. Oops. And what they really are shell scripts that utilize Java in the background to interface with ec2. So that's one way of doing it. You can also do it programmatically if you have a Python library called Boto, B-O-T-O. That is an implementation in Python for interfacing with the programming interface. And another way that I certainly like, but it has its limitations, is a Firefox add-on called Elastic Fox. And what Elastic Fox allows you to do is to choose an image. Remember we saw that picture with all those different machines? Well, it doesn't look quite as pretty, but these here, all of those are different Amazon machines. So it can get quite confusing to choose which machine you want to run, because they have quite a lot of different machines. And these machine images vary. Some of them are plain, just what you'd get if you install a bare bones operating system. And some of them are ready-made with other applications. I actually created a plone Amazon machine image. It's still a little too specific. I need to kind of clean it up a bit. And I guess I could make that available to people in the community as an image that you could just launch and have plone running in the cloud right away. And you can create other customized ones. Right now, there are quite a few for PHP-related projects, and I know there's at least a Django one and so on. So this is Elastic Fox, which is another way of interfacing with the API tools. Of course, you're going to need plone, build out, and plone's ec2 shell scripts, which these are some scripts I've been kind of putting together to manage ec2 with plone. So how to go about it? You're going to want to prepare your tools, and I'll go through that. That's going to be a little more command line intensive, so I'm warning you from now. And then you launch your machine image. So let's see if we can quickly kind of look at that. And we'll also talk about setting up your Elastic IP, DNS, setting up your block storage, and then running some deploy scripts. Okay? How am I for time? Okay, I guess that's all right. If you're setting up the default tools, you're going to need to have Java. So just make sure your operating system has Java set up. I've tested this on a Mac, and I've tested it on a Linux system. It's a little bit different if you're doing it on Windows. So, I apologize, I haven't tried it on Windows. Mostly I just don't have Windows around, and so what you need to do, you need to make sure you have Java, and then what you're seeing here is the different environmental variables that need to be set in order for you to be able to run stuff properly. Now remember that certificate that I said you get when you sign up with Amazon Web Services? Well, you're going to want to get that certificate along with a private key, and just drop that in a directory, and that's what you're seeing here as ec2 cert, ec2 private key. You also need something called ec2 home, and ec2 home actually is where all those scripts I showed you a few moments ago, it needs to know where those scripts exist. What I decided to do was just add it to my path. So that's this little extra command here. And all of this, you can drop it into a bash profile file. I'm making a couple of assumptions here but if you don't, if you're not familiar with this, I'm sure you know a sysadmin or some other geek that will be able to set you up. You just drop it into your profile file or your bash RC. So if you're writing it down, just bash RC file, profile file. Okay, the other option is using Elastic Fox. And Elastic Fox actually does not use the same certificate, because there are two ways to go about it. You can get access credentials. So you can get an access key and a secret access key. So you can go into your account and just copy your access key and your super secret access key. And then over in Elastic you can actually add those things under credentials. So as you see, there are dots for the super secret one, and the access key, you just add it right there. Great. Okay, so back to the command line. So that's actually all you need to do to prepare your tools. Once you've prepared your tools, every time you open your terminal after that, you'll be able to run all those ec2 commands. Okay? Here's an example of an ec2 command. It's for the Elastic IP, and I'm going to have to give you a little background about that, because I'm realizing there's a little gap in my presentation. So let's jump to this slide first and explain what's happening. Now, one of the challenges with the ability to wake up a machine and put it back to sleep is there needs to be a way that you don't just store a generic username and password. Because if you're storing a generic username and password, that's going to be a problem, because somebody's going to get it and log into your machine when you launch it. So they don't store generic usernames and passwords on these machines generally as a policy. So it means that there needs to be a way at launch time to tell this machine enough that it will be able to let you in. And the way that they do this is using a secure key pair. So what you do is use a command and generate a key pair. And when you launch your instance using this command here, ec2 run instances, you can specify the key that you're launching with. And by specifying the key that you're launching your instance with, you're able to then use that key to authenticate into that instance as the root user. Okay? Let me break down this command a little more. This line here is actually the name of the Amazon machine image. So you need to actually choose what Amazon machine image you plan to launch with. This Amazon machine image is actually the latest Hori Ubuntu 8.04 long-term service release. And so once I do that, I would have launched a brand new instance. If internet is nice enough to me, maybe we could try that command and see what happens. So let's go to the command line here. And I'm just going to do this in a demo directory. So I'm now creating a key pair, and it's going to be called Super Secure Key. And it usually goes much faster than this. Right? Okay. We'll come back to that and see. Right. Once you've actually launched your instance, you usually will be able to find it on the list of instances. And there's a command line way of checking for your instances, or you could use Elastic to check for your instances. Luckily, since the net has decided to not cooperate, I do have some screenshots of some of this stuff. So let's look at some of this stuff. let's look at running an instance. Okay. Once an instance is launched, Amazon knows a lot about that instance. So for example, an instance has an instance ID. Can you see that there? Every instance gets a unique ID, and you use that ID all the time to interact with the instance. So it's important to be aware of the instance's unique ID. Let's go back to our command line and see. Oh, great! I already created that key pair. No problem. So since it's already there, I can now launch an instance. Oh, hold on, no. So just for fun, I'll create a second key pair. All right. Once you've actually created a key pair, and you don't have to do a key pair every time, by the way. You can use existing key pairs, but I'm just kind of doing this for demo. Once you have your key pair, you can use that key pair to launch your Amazon instance, and then you can actually log in with that key pair. So let's see. Great. So we've created our key pair, and now we're going to launch an instance using that key pair. By the way, in terms of choosing instances or Amazon machines, there's a really good website called elastic.com, not elastic.com, elastic.com. And at Elastic, you can get the names of different images that you may find useful. Okay, so the one that I chose was a 32-bit Hardy. Right, I said Hori previously, I meant Hardy. I thought I just created that key pair. Oh, super secure key pair. You know what? I'm just going to go to my SSH directory and use a key pair that I know works. Right. Once you have something running, it will look like this inside of Elastic Fox, and you can also get a report on the command line. If you're using Boto, which is the Python library, you can also query it via the API with some pretty nice tools. So you could write out a Python script, or even if you really want to be fancy, hook it into plone so you could monitor all your stuff through a plone interface. Okay. Once you have your machine up and running, you're going to want to set up a block storage. If you do not have a block storage, when you plug it out, your data is going to disappear. Previous to having a block storage, there were only two options. Option one was to throw your important data into an S3 storage, or to send it to a server that is not going to disappear when you plug it out. So what I was doing previous to Elastic Block Storage was actually sending my data across the internet to a server. And then I had a little script. It wasn't a big data file, so I had a script where I just launched my AMI, and then I pulled all my data down at boot time. But that's not necessarily practical as your data set grows. So this is why it is a simple plone implementation. So how does the block storage work? Let's look at that. Block storage. Right, there we go. This is how, well, this is actually a pointless screenshot. I could show you that over here. The block storage has volumes and snapshots. A volume is something that you get a snapshot from. So a volume can be thought of as a block or a hard drive, and you can create snapshots for a given volume. And all of them get unique IDs, so you can track everything based on their unique IDs. So as you see, I've done 3 snapshots here, and I have a volume which is associated with a specific instance, okay? And I decided I'll call my device dev SDP. In general, you want to name your device dev SD something, because that's the set of devices. Dev SDP helps me to remember I'm mounting plone data. So I just call it dev/SDP. And that also ensures it doesn't conflict with things down at SDA or SDB. Okay? But you can choose in terms of names. What happens when you do this is that it creates that block. It associates that block with that device. And then on your file system, when you log in, you can actually mount that device and format that device. So what I've done by mounting dev SDP is I would have basically have set up a block device. I can then, I said that already, I can format it, etc., etc. I also, in my script, I added it to the file system table, etcfs tab, trying to not go too deep into the Linux stuff. But the file system table makes sure that it knows how it should be mounted, and then I mounted it. Okay, mounting it means it's the equivalent of plugging in the thumb drive. So now you can have it at a location where you can now run your plone stuff. Okay. The final step is to run the deploy script. My deploy script, what I do is I actually pull down a build out, and it runs that build out. In fact, just to make things simpler, my deploy script also includes mounting the file system, the data-fs, and it also, not the data-fs, the block device, and then it pulls down the build-out stuff onto that block device and launches plone. Okay? Other considerations that you're going to want to think about. There are other approaches to this. One of the things I hinted at was actually creating your own custom AMI, meaning your own machine image. And I have done that, and it takes a while to build your own machine image. And so to date, last I checked, you had to store that machine image in S3 storage. Once you have that machine image, you can then launch it. It has its own AMI ID and everything, so you can actually launch that image, and you'd have a ready-made plone. In terms of operating costs, a small instance roughly costs about, I think it's like about 10 cents per minute, or is that per hour? It's per hour, right? Which mean per minute would be crazy. Uh, it's per hour, and that means it costs about $72 to $74 per month if you have it plugged in and running all the time. You get about 1.4 gigs or 1.7 gigs of memory, and it runs at the equivalent of about a 1.7 gigahertz processor. But there are people who argue about that in terms of how you measure it and benchmark it. So if you're comparing that to what is in the hosting market now, an unmanaged server is probably going to run you closer to 90 or more per month for comparable power. And even a VPS you probably won't be able to get the same type of stuff off of a VPS. In terms of improvements, the script that I have done, and you can speak to me about it afterwards, it doesn't fully automate everything. I'm hoping in the near future to automate everything. Another thing is with the elastic IP, you can now associate an IP address that doesn't change with your project. So even if you put your box to sleep and wake it back up, you can put an elastic IP with the same IP address there again. Now I see some people that like, yeah, that's great. The reason that's good is because in your domain name server, which says what your web address is, it doesn't like your IP address changing all the time, and there are a lot of problems that happen if your IP address changes all the time. So having an IP address that stays the same means you just have to set it once in your domain name server, and you can do that with Amazon's elastic IP. Okay, so I've started using that, and that has helped, so that's an improvement as well. Another thing that you can do is you can actually take 2 instances, and then you could have a script that basically switches which instance is using the IP address. So you can have a situation where here's your machine that's live, here's your machine that is being configured and tinkered with, and then at any point in time, when you're ready to go, you can just say, all right, let's pass the IP to this one now that it's ready. And as long as they're synchronized, okay, great. If you want to get more about the costs, you can go to this address, and I'll just jump through a couple more ideas for improvement. By the way, thanks to Steve McMahon for the feedback about operating costs. That was a good reminder. Amazon has a service called DevPay, and DevPay would make it possible for you to actually have a payment system built right in. So that would be great to build into a solution. For simple deployments, Dylan J from PretoWeb has his dream of a build-out recipe that deploys everything to ec2, so actually integrating all your scripts into build-out. So if you can imagine on ec2 being able to just have a build-out that goes, and ec2 is ready. Spawning new boxes on demand, so monitoring your load and then launching a new box when your load gets too high and load balancing it. Right, so those are some possible improvements and some ideas. My last comment is about performance. There's a significant improvement when you use block storage versus just using the machine in the cloud as it is. I don't know all the details why it's so much better. I have like about 30 seconds, so if you have a question. How much storage? On the default, they have two block devices on the default. The first one is like about 4 to 8 gigs, I think, but there's a larger one on Dev SDB, which is about 140 gigs. And I was actually using that before they had EBS. And what I'd do is I'd make sure my DataFS serves from there, and then I'd shoot it off to my server. And then when I want to wake it up again, I'd bring it back down to the 140 gig partition. But it's not mounted by default, so you'd have to mount that.
So when we set up a server, like a normal server, we've got all these things assigned from things that are configured by build-out. So like it's Apache server configuration, there's cron jobs.
Right.
How are you handling those?
Right. Shell scripts. So I know there is this thing called Puppet, which is a tool that can manage configurations kind of as you launch your instance. But I've been using shell scripts, and basically what you can do is just run that shell script, and as long as you have all the magic in the shell script, it will pull down everything. There are some issues because you're dependent on another external service, whether it be your repository or PyPy or something like that, and that can be problematic. Okay, I'm done. All right. Sure.
Thank